Welcome back, class. This is Math 45, and we'll be going over section 3.3. I'm your instructor, Cindy Enrigue, and I'm happy to help you. So here we go. So for section 3.3, we want to be looking at the behavior of graphs. So we're going to be analyzing graphs to determine whether they're increasing, decreasing, or constant. And really, you just want to really look at the slope. If you have a positive slope, then you know that you are going to be increasing. And remember, we read graphs left to right. If you have a negative slope, then that's going to be decreasing. And if you have a slope that's left to right, meaning this is slope of 0, then this is constant. So those are the three different graphs that we want to be analyzing. So increasing, decreasing, and constant. And remember, the way that you read graphs is left to right. So read graphs left to right. Okay, so we want to know the intervals for which the function is increasing, decreasing, or constant. So we're going to be kind of highlighting what we see. So I can see here that I have a negative slope. I also see a negative slope here, okay? So we are going to say that it's going to be decreasing on those intervals. So that interval, it looks like since this is going up and over, it's at negative infinity. And this point right here, that point of inflection, where it goes from negative to positive slope, that point is -2, -7. So that means this here, since it's going off to negative infinity, that we are going to have this going from negative infinity to -2. We want to make sure that we are using our interval notation. So remember that interval notation. Union, and we have to kind of consider the second interval here. So this point right in there, it looks like that 0, 3, and this graph is going over towards positive infinity. So this is going from, as well, 0 to a positive infinity for the decreasing. Now, if I want to see where it's increasing, it's right in here. That's the blue part. So it's increasing. Oops. Let's get back there. Didn't mean to do that. So it's increasing on the blue highlighter. So we already know the points there. So we just know we're going to take the x values. It goes from -2 to 0. And it's going to be parentheses because at this point it's a negative and a positive slope. That point is a negative and positive slope. So that's why we specifically want to use parentheses around that. And of course, the last thing that it wants us to identify is it wants to identify where it's constant. So where is it going left to right? Where does it have a slope of 0? It doesn't. Therefore, we are going to say none. Okay? It's not there. All right. So we're going to keep analyzing some of these graphs. So I'm looking at the graphs and I'm like, okay, well, we want to know where it's going to be decreasing. Well, this slope goes up. Okay, here it starts to go down. That's negative. And this is also going to be negative. So I want to represent those intervals. So it's going to be decreasing on those intervals. So this point is going to be -5, 2. This point right in there is a -2, like a -0.5. The y value doesn't matter much. The x value is what matters the most. And over here we have a 2, maybe like a 5.5. And over here, this is going off towards positive infinity. So now I can identify my decreasing intervals. I know I'm going to go from -5 to -2. And then the second yellow highlighted part, that interval is represented by 2, positive infinity. So now I want to see where this is going to be increasing. So this is a positive slope, and that's a positive slope. So we want to go ahead and represent that. So where it's increasing. So it looks like over here, this is going down, 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 down. You can kind of think of it as going towards negative infinity. So it's increasing from negative infinity towards -5, union, and where it's blue again at -2 to +2. Okay. And the last thing we want to know is where it's going to be constant. And again, in this particular example, there is none. Okay. So now looking at part D, we're going to do the exact same thing here. So we know that we want to be looking at our intervals of decreasing. Well, this is a positive slope, constant, positive. So actually, I'm going to say for my decreasing, I have none. Okay. For my increasing, that's here and here. So increasing, I have 2 different intervals. This point right in here is going to be 0. Oops, sorry about that, guys. That's going to be 0, 5. And this point right in there looks like it's 4, 5 as well. So the important thing is our x values. So that x value is 0 and that x value is 4. So I know that I'm increasing from negative infinity to 0, union 4 to positive infinity. And for constant, this is where your slope is 0. That's right in here. So you're just like, okay, constant. That's going to be between 0 and 4. Now I can surely see that that's what that graph is representing. So we have our increasing, our decreasing, and our constant. The next thing we want to identify is our local minima and local maxima, and our absolute maximum and our absolute minima. So here we want to find the local minimum and maximums. So our local max and min. So remember from our definition from our local max and min, that's over here. We want to know for which the function is an increasing function on the open interval for the y values at point B is greater than point A. Okay. So let's think about this. So our local maximum, it looks like we have a maximum right in here. That's a high point, okay? So that point is going to be -1, 1. So that's going to be our local max. Okay. The other thing that we have is we have a local minimum. It's our low point. This point is represented by 2, -3. So this is our local minimum point. Here, it looks like these points are already kind of pointed out for us. So this point looks like it's a high point, so it's a maximum. So this is a local max. And that ordered pair is at -6, +4. And I also have this point over here that's represented for me. And that point is a -1, 1, and that's our local min. So you're just making sure that when you look at these graphs, you're like, okay, what's a high point? What's a low point? That's going to represent your local max and your local min. Now, if I'm finding the absolute maximum and the absolute minimum, we want to represent which is the very highest and the very lowest. So it seems like this point right here is very high. So that is going to be my absolute maximum. And that ordered pair, the x value is 5 and the y value is 12. Okay. The other point that we have is we have this point right there. And we also have a point right in there. So since we want the local minimum, well, this one down here is lower than this one. So this one's going to be our absolute minimum. This one over here, we can think that that's going to be a local min. But that's not what the question is asking us. They specifically want for the absolute minimum. So you're just like, okay, well that point in particular, the x value is -1 and the y value is 0. So that's going to represent my absolute minimum. So looking at this graph, I have pointed out the absolute max and the absolute minimum. And that is it for section 3.3. If you have any questions, please feel free to email me and I'll go ahead and help you with that.